Okay, for number 14, we need the formula sheet. So flip back to the cover and you will see the parametric equations for projectile motion, because we've got Chloe who kicks a soccer ball to her friend. So we've got an x equals and a y equals. V sub 0 is the initial velocity, that's 35. At an angle of, that's supposed to say 40 degrees, of 40 degrees times t. And then negative 16t squared plus 35 sine 40t plus an initial height of 1.5. And now we need to go to the calculator. In mode, make sure you have degree and parametric mode. We would arrow down to them and press enter. Then we're going to go to y equals and type in everything we just wrote. Okay. The rest of this is all about setting up the calculator so that it gives us a nice picture. So we're going to go to Window, and mine are left over from classwork. But you want your T minimum to be 0, your T maximum to be 10, your T step to be 0.1. And now 800 for X max, that is way too big. Kicking a ball, I think I can go 100. Let's see, or Chloe. Y max, let's also put that 100. Okay, so I've got all this extra white space. It's fine. We could make the window shorter so that we don't have all that extra white space. Well, now it looks okay. It doesn't matter as long as you can see the entire path of the ball. And we're going to press the trace button. And the first question says, find the maximum height, the time it is reached, and how far horizontally. Okay, whoops. So we want to arrow over to the vertex, and we're going to watch the y value to see which is the highest. Looks like 9.4 is. So the maximum height is 9.41 feet at 0.7 seconds. When the x is 18.77 feet away. That's the horizontal. Okay, how long is the ball in the air and how far from Chloe is that? So that's the x-intercept over here. So we're going to arrow to the right. And we want the y to be as close to 0 as possible. Looks like it's that one. So how long the ball is in the air for 1.5 seconds. And it is at 40.22 feet away. All right, on the next page, we've got the no calculator section. A vector is represented by -2, 2. Let's graph that. -2, 2, that's in quadrant 2. What is the magnitude and the direction? Okay, so magnitude is the square root of x squared plus y squared. That's the square root of 8. Let's simplify the square root of 8. What two numbers multiply to 8, one of them being a perfect square? I hope you thought about 4 and 2. because now we can think of this as the square root of 4 times the square root of 2. And the square root of 4 is 2, and the square root of 2 stays. So 2 correct answers. The square root of 8 is the magnitude, but that also simplifies to 2 root 2. For the magnitude, we're going to do, for the direction, tangent inverse of y over x. And I know you're probably thinking, but this is the no calculator section, Miss Weiss. How am I supposed to do this? Well, tangent inverse of 1 is saying what angle gives you a tangent of 1 over 1. And that is 45 degrees. So our reference angle is 45, which means the direction is 180 minus 45 for a direction of 135 degrees. All right, let's try that again with 16. Oh, I kind of already drew this picture with my trig answer above. So we've got 1, 1. So the magnitude is the square root of 1 squared plus 1 squared. That's the square root of 2. And we've got tangent inverse. That's another 45-degree angle. And that actually is the direction because our vector is in quadrant 1. Okay, moving right along. Simplify or prove the expressions. So part A and C are simplify. I don't know what the answer should be. And B and D are prove. Okay. You'll get your formula sheet again. All right, I took a screenshot for us here. And to simplify in A, I want to replace or manipulate one of my identities around so that I can fix the numerator. And I notice here I can replace 1 with sine squared plus cosine squared. So let's do that. So we're going to take the 1 and replace that with sine squared x plus cosine squared x. And then bring the rest of your equation down. In the numerator now, cosine squared minus cosine squared adds to 0. And we are left with sine squared x divided by sine x. If you are stuck on how to simplify that fraction, you can think of it as sine x times sine x divided by sine x. And sine divided by itself is 1. So our final answer is sine of x. Okay, let's try B. Oops. Okay. Anytime we have a fraction, I need a common denominator. And I know my answer is going to be cotangent times cosine, so don't touch the right side. We can only change one side. And so I need this fraction, the second fraction after the subtraction, to have a denominator of sine x. So that means I need to multiply the numerator by sine x. So that gives me sine squared x over sine x. And now that we have a common denominator, we can make this into one fraction. We're going to use the same Pythagorean identity, and I'm going to use a different strategy this time. I notice that if I subtract sine squared to the right side, that 1 minus sine squared would equal cosine squared. So that's more of a manipulate the identity to make it match what you have. If you're a replacement person, that's totally fine. You replace the 1 and keep simplifying your numerator. So I know my answer needs to be cotangent times cosine. So I'm going to think of cosine squared as cosine x times cosine x divided by sine x. And we are one step away because cosine divided by sine is cotangent. Keep the other cosine, and we did it. That equals what we wanted. Okay, for C, I'm going to change cotangent into 1 over tangent. Use that reciprocal identity. Because now this first part of my problem, tangent divided by itself, simplifies to 1. You can manipulate, right? We can subtract sine squared to the right, or I'll replace 1 with sine squared plus cosine squared. Bring down the rest. And then we've got sine squared minus itself, so we are left with cosine squared alpha. All right, here we go for D. Needed a little more space. Okay. I can think of 2 ways to do this problem. I think I'm going to do both because why not? Okay, first way is to change cotangent into cosine over sine. And then we need to make a common denominator. So the 1 would be sine theta divided by sine theta. So it gives me sine theta over sine theta minus cosine theta over sine theta. And now that we have a common denominator, we can subtract. And there is our answer. We're done. I don't even need the formula sheet for that. Okay, here's the other way I can think of. Normally, we combine fractions to make a common denominator. I'm going to use that idea in reverse. On the right-hand side, I'm going to split up the common denominator. So because the entire fraction is divided by sine, I can take sine divided by sine minus cosine divided by sine. That leaves me with 1 minus cotangent theta, which we got. So both are acceptable ways to prove part D. What's next? More vectors. Okay. Vector W and Z are on a coordinate plane. Write the vectors in component form. W moves 5 units left and 6 units down. So those are negative directions. So I've got -5, -6. Z moves 7 units right and 10 units up. So 7 to the right and 10 up. Which vector has the greater magnitude? So vector W is 5 squared plus 6 squared. That is 61. All right, Z. That is the square root of 149. So the greater magnitude would be vector Z. That is the longer vector. If you're not sure, it's the no calculator section. When we're comparing square roots, Let's see, the closest perfect square to 61 is the square root of 64, which is 8. And a nice perfect square with 149, I don't know, even if we did a square root of 100, that's 10. So the z value is longer. Calculate the following. Okay, hang on. Okay, adding the vectors together, we are going to add the x's, so negative 5 plus 7 for the x component, negative 6 plus 10 for the y component, so we get 2, 4. Z minus w. So the order with subtraction matters, so let me rewrite this. So the x component would be 7 minus negative 5, and the y component 10 minus negative 6. So that's really minus a negative is like adding. So we get 12, 16. Eliminate the parameter, write your answer in slope-intercept form, meaning isolate the y. Okay. I still am going to use elimination method. So I will multiply the y equation here by negative 2 so that I get a positive 2t coefficient, which will eliminate with the negative 2t in the x equation. So we're going to add these together. Okay, so we've eliminated the parameter, but now we have to write this in slope-intercept form, which means isolate the y. So we're going to subtract x from both sides. And we're going to divide every single piece by negative 2. So we get y equals positive 1/2 x, because there's the invisible 1 here, plus 3 over 2. In problem B, we need the 5t and 2t to multiply to be something that is the same so that we can add our equations together and eliminate the t. So I'm going to make the x equation times negative 2, the y equation times 5. I'm going to add these together. And now to isolate y, we're going to PEMDAS backwards. Let's add the 2x to the right. And divide every single piece by 5. So y equals 2/5 x plus 11/5. Okay, and you're finished. Good job.